Alright, hello and welcome to Lab 10. So in this one you're going to be calculating the square root of a number from scratch, so you're not going to use any libraries or anything like that. And you're just going to practice what we learned about when we talked about binary search. So you're going to repeatedly guess where you think a square root should be, and eventually you're going to get to the right place. So go ahead and get all the code, and then you are ready. So the main file that you'll be implementing is this square root test and square root.cpp. So these two files right here, those will be the ones that you turn in. Okay, so let's look at square root.h first. So there's only two functions that you are going to use in this lab: approx equal and square root. Okay, so you'll be implementing both of those. The first one is just, hey, return true if these two numbers are really, really close to each other. That shouldn't be hard. And then square root is going to be the main function that you work on for this lab. Okay, so just given some double x, return the square root of that number. Okay, and also if it is less than 0, because there is no square root of a number less than 0 in terms of doubles, you have to start getting into complex numbers, right? In that case, you just throw a runtime error with whatever string you want to throw inside of it. Okay, so that's all you do there. And let's see if I can get it to go to the other desktop for a second. All right, so here is the idea again. So you're going to repeatedly make all these guesses until your guess becomes approximately equal to, hey, you're going to use that function to the real square root. Okay, throwing a runtime error if you get a negative x again. So at the very beginning, you have to come up with a search space, like where you believe that the square root should be, and we're going to search inside of that space. So you have to pick some range of values where you know the square root must lie. Okay, so at the very beginning of your function, you have to pick this, and I have given you the answer here. In fact, so square roots can't get smaller than 0. So just make your lower limit 0, and your upper limit, the right side, the max of 1 and the number x, okay? Or x plus 1. Either one of those would work as an upper limit. So, for example, if you were given square root of 9, you wanted to find the square root of 9, you would set your search space initially to be, okay, the square root of 9 must be between 0 and 9 somewhere. We're going to go look for it, okay? That's what's going to happen. And you're going to keep on calculating the midpoint of your current search space. You've got a low end, you've got a high end. Calculate the middle. Originally, it's going to be 4.5, right? And you're going to notice that it's too high. You need to cut off that amount of space, okay? So you're going to keep on guessing and seeing if your guess is good enough. And the midpoint of your search space is your guess. So here, I have taken my solution and coded up some cout statements inside of it to show you exactly how your program should think once you've implemented it correctly. Okay, so use all of these lines to help you get to the right answer. All right, so from the beginning, we start out with a lower limit of 0 and upper limit of 9, pretending that we're called with 9. That should work for every number, right? So x is 9. Lower limit 0, upper limit's 9. We're going to calculate the midpoint. That's 4.5. And then to see if we were in the right spot, we're going to square the midpoint. Okay? That is the key. And so 4.5 squared is way over here. Like, it wasn't the 9 that we were looking for. Okay? So it can't be. 4.5 can't be the square root. That was too high. So we'll guess lower. And so we'll change the upper limit to be not as big. Okay? And now we're in iteration number 2. We've changed our upper limit to be the old midpoint. Okay, that's what you do. The old midpoint becomes one of your new limits. Okay, and again, you'll make a guess. Like, okay, now I'm the midpoint of between 0 and 4.5. Let me actually zoom in for this. The midpoint between 0 and 4.5, oh, that is 2.25. Let's guess there. And we'll square 2.25. That was smaller, so you'll get a smaller number than 9. And so that was too low. We need to guess higher now. Okay? So we'll change the lower limit to make sure that we guess higher. Okay, so now the lower limit becomes the old mid. Sorry. I hope that makes sense. Okay. And then you'll just keep on going like that, cutting off your search space. Eventually, you'll guess high again. then you'll change the upper limit. And so now you know that the square root must be between 2.25 and 3.375, and you're going to keep on following this process. Okay? On and on and on until iteration number 25, it seems, for this one. It might converge faster for some inputs than others. Finally, then, we've got a lower limit that's really close to 3, an upper limit that's really, really close to 3. We're going to get the midpoint of that, and it's really, really close to 3. And we're going to square it. And that is finally, according to our definition of approximately equal, within that little tiny amount, it's good enough. So we're going to return back mid as the answer. Okay, I hope that makes sense. That's your final answer. You're just going to keep on cutting off sides of this graph until you find that square root. Okay, and it'll always work because the square root is increasing. Okay, you'll never pass it. And yeah, that's all you're going to do. So once you got that working, life is a breeze. Just write get my tests to pass. You're going to use the make file to compile your code. You're going to say make square root test, and then run it with /square root test. And yeah, you're going to add 4 more tests in addition to mine, and that's it. So that's the one other file you'll worry about, square root test. And you'll just add some more tests down here and into this class. And you can see that mine are testing your square root of 2, square root of 0.5, and square root of -1. So that one should throw an exception. Okay, yeah, that's all I got for you. This one shouldn't be too bad. You've done all the hard things in this class, really. I think that recursion was the last really, really hard topic. So the rest of this class is really not going to be bad, I don't think. So yeah, enjoy this lab. Hopefully it's fun to learn how the libraries in C++, like the math library, are actually working. They're doing something similar to this for some platforms. And yeah, that's all I got for you. So you'll turn in those 2 files, square root.cpp and square root test.cpp. And that's all. All right, good luck. And please yell at me if you have any questions. I'll see you later.